Hello and welcome to my channel AI with Grounding. In our RAG evolution roadmap, we reach our next step, which is keyword RAG. In the last step, we had keyword retrieval, where we asked questions and we got back a list of results. And then something interesting happened. The system stopped working and we started working. We had to read the results, compare them, and figure out the answers ourselves. So technically, the system did the retrieval, but practically, we were still doing the reasoning. And that's a serious limitation, because if the user has to do the thinking, then what exactly is the system solving? Now, ideally, we would want an assistant to do this for us. Someone who can read the results, connect the dots, and explain the answer. And fortunately, we do have one. Let's see who this assistant is and how it changes the system. So here is our assistant, the LLM. But not as a chatbot, not as something that answers from memory. Here it has a specific role. It sits on top of retrieval. It reads the result we fetch, filters what matters, and explains the answer. Think of it like this. Earlier the system gave you a pile of notes and you had to make sense of them. Now the system gives those notes to the LLM and the LLM does the thinking for you. So the system shifts from just finding information to actually using that information. From retrieval to retrieval plus grounded generation. And grounded is important because the LLM is not free to say anything. It can only speak from what it sees. No extra knowledge, no assumption, just reasoning over retrieved evidence. Let's see how this actually works inside the system. The first part doesn't change. User asks a question and we run keyword search. Same TF-IDF, same cosine similarity, same word matching logic we saw earlier. We still get a list of documents, nothing smarter yet. But now comes the new part. Instead of sending those results to the user, we pass them to the LLM. And we don't just dump raw data. We give it structured context, clean snippets, readable text. And now the LLM has something it can actually understand. And then we ask it, answer the question using only this. So the pipeline becomes user to keyword retrieval to context to LLM and then finally get the answer. And here is the interesting part. We didn't make retrieval smarter. We just added a reasoning layer on top. So if retrieval gives good evidence, the LLM looks smart. If the retrieval gives weak evidences, the LLM can only work with that. It's like asking a very intelligent analyst to write a report, but only giving them half of the documents. They will still write well, but they can't invent what's missing. Now let's translate that flow into code. And you will notice something interesting. There's no magic here. It's just a few well-defined steps. First, keyword search. This is exactly what we already had. Fast, simple, word-based retrieval, no intelligence added yet. Second, we take those results and convert them into readable snippets because raw tables don't have the model. If you give it columns and IDs, it just stares back at you. So we reshape the data into something closer to language. And then comes the important part. Answer from snippets. This is where the LLM comes in. We pass the question, we pass the context, and we give it a very strict instruction. Answer only from what you see. So the flow becomes retrieve, format, constraint, and finally answer. Each step is simple, but together they create something much more powerful than just search. Because now the system is not just retrieving data, it is interpreting it. Now if you look at the tools we are using here, nothing feels particularly advanced. Pandas for handling data, TF-IDF for retrieval, and LLM for answering. Individually, these all are very standard. In fact, none of them are new. So what changed? Not the tool. The role of the tools. Earlier, retrieval was the final step. Now retrieval is just the input to something else. And the LLM is no longer acting like a chatbot. It's acting like an analyst. It reads the evidence, filters what matters, and explains the answer. And here is the subtle shift. The intelligence is not in any one component. It is in how they are connected. Because when you connect simple pieces correctly, you don't get a slightly better system. You get a fundamentally different one. Let's see the code. Before running this code, you need an OpenAI API key. For that, you need to go to platform.openai.com/API-keys URL. Sign in and click on Create New Secret Key. Then create a .env file in your project folder and add this line OpenAI_API_key is equal to the key which you got from OpenAI platform. That's it. Okay, we start by importing the required libraries. For OpenAI, we are using from OpenAI, import OpenAI, bring the OpenAI client so we can call the language model. import OS to access environment variable from the system, and from .env, let us load values from a local .env file, which is the simplest way to keep an API key outside the code. Then we call the load underscore .env. This reads the .env file and makes the values available to Python as environment variables. Next, we read the OpenAI API key using this command. So instead of hard coding the key directly into the notebook, we pull it from the environment. This is the safest and cleaner way. Then we create the client using this command. This client is what we will use to talk to the model. Now comes the main function. Answer from snippets. This function takes two inputs. First, the user question. Second, the retrieve snippets that comes from our keyword search. Its job is simple. Build a strict prompt, send it to the LLM, and return the answer. Inside the function, we create a prompt using the F string. This prompt is doing most of the heavy lifting. We tell the model, you are a grounded QA assistant and you must only use the snippet below. This part is critical because at this stage, we do not want the model to behave like a general chatbot. We want it to behave like a constrained assistant that can answer only from retrieved evidences. Then we had some hard rules. First rule says every factual claim must be a citation like S1, S2. This forces traceability. The second rule is even stricter. If the answer includes a person name like an actor or director, the model must include the exact quote containing the name from the snippet. This is important because person name questions are where hallucination become very obvious. So we are pushing the model to prove it really saw the name in the data. Then we had another rule. If quoted evidence is missing, just simply reply not found in data. This is actually a very powerful design choice because silence is better than fake confidence. Instead of forcing an answer, we allow the system to fail safely. We also explicitly say, do not use outside knowledge or do not guess. Again, this is about grounding. Then we define the output structure. Part A is evidence, hence the model should only show the quoted lines needed to support the answer. Part B is the final answer. The final answer should be a bullet point and every bullet must end with citation. And there is one more instruction for overlap style questions, output only in intersection, not the union. This prevents the model from mixing related items with truly shared items. After all the rules, we inject the actual retrieve snippets and the user's question into the prompt. So this whole prompt is basically our guardrail layer. Next, we send this prompt to the model using this command. We choose the model GPT-4o mini. This gives us a lightweight LLM call for these steps. And this is quite cheap also. We pass the prompt as a user message and we set temperature equal to 0.3. This means we want the model to be less creative and more consistent. For a grounded QA task, lower creativity is usually better. Then we return the choice 0. So the function gives us back only the text of the model's answer. Now let's look at the second function. Format hits DF for LLM. This function prepares a retrieve result before sending them to the model because the LLM does not understand a pandas data frame directly in a structured or reliable way. So we convert each row into a clean text block. We start with an empty list called blocks. Then we loop through each row in the data frame using enumerate, start from 1. For every result, we build a formatted snippet like this. Snippet number, movie title, year, genres, rating, director, and cast. For example, each result becomes something like S1, movie name, year, then genre, rating, director, and cast. This is very important because now every retrieve result has a stable label like S1, S2, S3. And those labels are exactly what the model used for citation. So this function is what connects retrieval to explainability. Without this formatting step, the model would not have a clear citation structure to refer to. Finally, we join all these blocks together with blank lines in between and return one long text string. This string becomes the snippet's input for the first function. So the overall flow is this. First, keyword search gives us matching records. Then format hits DF for LLM converts these records into labeled snippet blocks. Then answer from snippets build a strict prompt around those snippets. Then the LLM tries to answer using only that evidence. So this code is not just calling an LLM, it is trying to control the LLM. And that is the real point of this step. We are already seeing an important idea in RAG. Retrieval alone is not enough. The LLM alone is not enough. We need structure, evidence, and constraint. Now let's run the system and see what kind of answer we are getting. So for question 1, we ask, recommend movies like Interstellar, emotional, cerebral, sci-fi. And the system says not found in data. That looks like a failure, but it's actually a good failure. Because this question requires understanding, interpretation, and reasoning. Our snippets only contain structured metadata, title, genres, rating, cast. There's no textual evidence subscribing emotional like cerebral or emotional. So the model refuses to answer. That's exactly what we told it to do. No evidence, no answer. For question 2, list top rated sci-fi movies after 2010. Again, not found in data. Why? Because this is not a simple lookup. This requires filtering by genre, filtering by year, sorting by rating. It's a multi-step reasoning. A system just retrieves snippets. It does not compute or rank. So again, the model refuses. Correct behavior. Now look at this one. What movies did Leonardo DiCaprio acted in around 2010 to 2015? This time it works. Why? Because the snippet explicitly contains the cast. So the model can directly match the name which is present in snippet and movies tied to the snippet. And it gives correct answer. This is a pure retrieval problem, no reasoning needed, just matching, and that's where this system works well. Now this one is interesting. Do the Matrix and John Wick share actors? And the system correctly finds the answer, because both names appear in both snippets. So this is a simple overlap detection problem, still manageable with retrieval plus basic LLM reasoning. So this system works well when the answer is directly present in the data or requires simple matching. But it fails when the question needs reasoning or requires interpretation beyond the snippets. Okay, let's evaluate the result. For question 1, which tests relevance, the system doesn't understand meaning. It only matches exact words. If a movie is similar in theme but doesn't share those keywords, it might never appear. For question 2, keyword search will again match words like sci-fi and 2010, but it doesn't really understand filtering logic. It just ranks document with similar terms. For question 3, keyword search will simply match the name Leonardo DiCaprio inside the cast field. There's no understanding of time range or actor relationship whatsoever. Question 4 requires reasoning across two movies and their cast list. Keyword search has no concept of relationship, so it will usually fail or return random results. So this is where things should start feeling better. Instead of scanning multiple documents, you expect a clean answer. Instead of guessing evidences, you expect reasoning. And for the first time, the system feels like it is trying to help, not just returning data. Also notice something subtle. The model doesn't just repeat text, it connects pieces, filters noise, and presents a coherent answer. So even with basic retrieval, the experience improves, at least in theory, because this is the point where expectation goes up and reality is about to check us. Now let's talk about what actually happened. When we ran this system, it didn't give a wrong answer. It didn't hallucinate. It simply said, I don't have enough information. And that feels like failure. But it's actually something much more important. The system is being honest because the LLM is doing exactly what we told to. Only answer from what you see. And that it sees depends entirely on retrieval. If the right evidence doesn't show up, the model has nothing to work with. And here is the key insight. An LLM is not a magician. It is a very articulate professor. It can organize information beautifully, but it cannot create missing facts. So if retrieval is weak, the system doesn't just degrade, it stops. No drama, no hallucinations, just silence. And the silence tells us exactly where the real problem is, retrieval. Because in this setup, garbage retrieval in, very well worded, nothing out. Okay, so we added an LLM, we expected better answers, but instead we got silence. And that might feels like a step back, but it is actually progress. Because for the first time, the system refused to guess. It stayed within its boundaries. And that's important. Because in real system, accuracy matters more than confidence. This step may not have given us great result, but it showed us exactly where the problem is, in the retrieval. And that sets up everything that comes next. Because once you see the limitation clearly, you can start fixing it. And remember, silence from a grounded system is better than confidence from a hallucinating one. This is it for this video. See you in the next one. Bye for now. And as always, explore AI but with grounding. Thanks for your time.